Okay, we can go ahead and get started. Welcome to my session on building identity foundations for an agentic future. Reason we're doing this talk is over the past year, we've seen a fundamental shift in how identity is managed, not just for people, but for agents acting on their behalf. And so let's talk about what that really means for builders in fintech. Some background about me. My name is Anvi Banga. I'm a developer relations engineer here at Descope. So for a bit of background, not everyone is familiar with what developer relations engineer really means. My job is quite varied. I do technical demos. I create content, like sample apps, blogs, videos to make it easier for developers to integrate our product. I work with our product management team on kind of the ideation and prioritization behind new features. And then I also represent Descope at conferences like this one. So overall, my day-to-day primary goal is to understand customers' needs, offer solutions, and ensure they have all that they need to be successful. So role takes many forms, but the short of it is that I help developers build secure authentication for complex workflows. And I've spent the last year helping developers untangle their problems with authentication and authorization from everything from single sign-on to now AI agents. So as a part of that, I've seen that the old assumptions we've held about identity, they're starting to break in some places. So in this talk, I hope you'll learn how to evolve your identity model beyond just human users, authorization patterns for delegation and agent control, as well as best practices for auditability, consent, and AI readiness. So let's ground this in reality with a few examples, because I know people use the term agent in all different kinds of ways. So let's talk about what I'm actually talking about when I say agentic. So when I say agentic, I mean real-world use cases where systems act semi or fully autonomously. These kinds of applications aren't really far off dreams anymore. I know, like, not that many people were talking about this even a year ago, but now, these applications are starting to become realities, and they're actually shipping today. So for fintech specifically, I'm talking about maybe auto-approving wire transfers under a certain threshold, and maybe even asking a human for additional permissions over the threshold. Maybe an LLM summarizing a user's portfolio and presenting it to them, sending them email with a summary every day. An agent syncing account activity across multiple platforms. Or maybe rebalancing a portfolio given certain risk parameters. So in each of these cases, the agent needs access, but it only needs limited access. And it should act only under certain specific constraints. And it also needs to leave a traceable record of what it did. And that's what identity infrastructure needs to be able to support. So fintech is in the middle of an evolution. These use cases are becoming very common now. And historically, all actions came directly from a human user. But today, we have agents making decisions and taking actions programmatically. So unlike traditional clients, these agents don't log in, do a thing, and then log back out. They are long-lived and stateful, and they're making autonomous decisions across hours or days. And these aren't speculative ideas. Like I said, we're seeing production systems that need to answer questions like, what agent is acting? What user authorized it? What is the context? So without identity infrastructure to back that up, these workflows can't scale securely. And because agents, especially LLMs, aren't deterministic, you can't rely on them to always follow instructions. We all know that agents can hallucinate instructions or capabilities or fabricate results. I'm sure all of us have spent some time angrily yelling at ChatGPT and being like, no, that doesn't make any sense. Try again. So we can't trust the LLMs to do that enforcement of what they're authorized to do. So identity and access enforcement must happen at the API and tool level, not just in the model layer. Security doesn't come from prompting. It comes from protocols. So in fintech, you need to you want smart automation, but you also need auditability, compliance, and a great user experience. And so let's look at some of the agentic identity drivers that we're seeing in fintech and in other fields to see why this is becoming more urgent. So the first one, obviously, is security. 5 of the top 10 OWASP for Gen AI threats have authentication and authorization-related mitigations. Gartner estimates AI agents will reduce time to exploit exposed accounts by 50% in 2027. The second driver is interoperability and scale. Non-human identities, such as APIs, tokens, bots, they outnumber human identities by 20 to 1 already, which means we need standardized and secure adoption of key protocols like OAuth, MCP, A2A. The third one is production readiness. So less than 2/5 of AI projects have successfully transitioned to production. And many AI initiatives stall at the identity layer because a lot of developer time and effort has to be spent into doing all of this, following all these protocols. So what's holding us back? We need to make sure that the agent can do 4 things, or has 4 things. The questions are, how do you make sure the agent is authenticated? So the user delegating identity has proven their identity to the system using a recognized method, typically something they know, like a password, something they have, like a device, or something they are, like biometrics, Face ID or Touch ID, or something of the sort. The second thing is the agent authorized? The authenticated entity has to be granted permission to perform the specific action on the specified resource. The third is, does the agent have user consent? The user has to explicitly allow an agent or system to perform an action or access data on their behalf. And the fourth key piece is, can the agent be audited later? Can we prove what happened, when, and why? Every identity-related action has to be traced, verified, and inspected by security, compliance, or debugging processes. And so think about like in a situation where a user might be giving consent to an agent, and then that agent is triggering another agent to perform an action on its behalf, the auditing has to reflect that entire chain of trust. So these are the 4 key pieces that every secure system must be able to answer. So why do traditional identity models break down? We outlined the key identity challenges already: is authenticated, is authorized, has user consent, and can be audited. So now let's talk about why traditional identity models break down when addressing these challenges. So traditional systems assume that a human logs in via some kind of UI, sessions are held via long-lived cookies or static tokens, and roles are generally assigned rather broadly, like you have an admin, you have a viewer, or roles like that, but they're not really specific to the resource that the user has access to. So agents don't use UIs. They need programmatic access. They require scoped, shorter-lived tokens, and they operate under much more dynamic user contexts. So essentially, we need identity that is dynamic, scoped, auditable, and API first. To break this down, let's look at some comparisons between how humans and AI surf the web, which is, spoiler alert, very differently. So humans react to UI and visual stimuli. AI agents and LLMs react to APIs and M2M communication. Humans point and click. AI agents use standard protocols like MCP or CUA. For humans, poor onboarding leads to drop-offs. For agents, incompatible APIs lead to drop-offs. For humans, poor security results in account takeovers. For agents, scope creep results in excessive agency, which means that agents end up doing actions that they don't have permission to do, like deleting your entire production environment. So in a world where AI agents and apps need to access your APIs, we need a secure, standardized way to grant access without relying on manual logins or permanent credentials. So that foundation is OAuth. So show of hands, how many of you are familiar with OAuth or have an idea? Oh, wow. This is a very identity-focused group. So for those of you who don't know, OAuth is the protocol behind that like login with Google button or the scary pop-ups that say, this app can view all of your contacts and take actions on everything on your behalf. So under the hood, it's much more than that. It gives us a structured way to handle delegation, scope, consent, and token lifecycle. So this makes OAuth the foundation, the backbone of secure agentic identity. So even if an LLM says it's acting on behalf of a user and like, trust me, believe me guys, like the user said I can do this thing, you can't trust the model to enforce the permissions or the boundaries. Hallucinations are a known behavior, and OAuth ensures that only authorized agents with valid tokens can actually perform the sensitive actions, no matter what the model says. So in this model, if an agent misuses a token or the server validates it, it's not a glitch or a user experience bug, it's a security breach. So that's why it is super, super important to know how to prepare your application to manage all of these OAuth protocols, because it's not like a recommended thing anymore. It's something that's becoming very mandatory. So before we go into how your app needs to utilize OAuth, let's do a quick background on what is OAuth, what are the protocols, and what are the different pieces of the puzzle. So quick review of the OAuth roles. You have the resource owner, which is the user or system that authorizes the client to access resources on their behalf. Then you have the resource server, which is the server that hosts the user's protected resources. Next, you have the client, which is the application that wants to access the user's protected resources on the user's behalf. And then you have the authorization server, which is the server responsible for the actual authorization and token generation piece of it. So the most common OAuth flow to give consent for agents acting on behalf of users is called authorization code flow. So in this flow, a user accesses a service, the client application. So the user is considered to be the resource owner, and the client application is the OAuth client. They grant access to the authorization server to the client application. This is generally like they'll sign in. So the client application will redirect to the authorization server's authorized URL. The user will sign in and prove that they are who they say they are. Then the authorization server issues an authorization code to the client application, and the client application then returns the authorization code to receive the access token. So this piece of it can actually happen in a couple different ways. If the client application is a confidential client, it's like a server-side app that's able to store a secret securely, it can use a client secret to get the access token in return. If not, there's a cool protocol called Proof Key for Code Exchange, or PKC. And so that's for apps that can't securely store secrets. And then it can use a code challenge and code verifier in lieu of the client secret. So I don't know if any of you guys saw at our booth earlier, we had shirts saying, I'm bringing PKC back. Now you know what PKC means. So then after the client application gets that access token, it can use that token to access the resource. So it hits the resource server's APIs with that token in the authentication header. So a lot of nerdy details, but critical to understand how this fits into your app. So if your app exposes APIs to agents or third-party tools, your app needs to act as an OAuth provider. That means you're not just verifying identity anymore, you're defining how apps, agents, or partners can access your APIs on behalf of the users. So let's go over what that involves. So the first piece of the puzzle is client registration. Every external app or agent that wants access to your API needs to be a registered OAuth client. So this can be done manually if you already know what clients are going to be accessing your resources, or it can be dynamically done upon connection using dynamic client registration, which we'll go into further detail later. And that's especially helpful if you're trying to support large-scale automation where you don't necessarily know in advance who will be accessing your resources. The next step, most important step, is managing user consent. And this is where nuance really matters. So this is just a consent screen. I gave all of my consent, all of pretty much blanket access to my iOS because I was trying to sign into my Google, into my mail from my phone. So I do want to actually delegate all of that to iOS. But so you can see generally, I'm sure you guys have all seen screens like this before, where you can say specifically what you want the app connecting to be able to do. So, and there are little checkboxes there, so if you want to give some control and not all, that's also an option. So when a client, so LLMs don't have a grounded concept of permissions unless you enforce it outside of the model. So that's why fine-grained scopes, you can even get finer-grained than this one. Like you can have separate ones for read and compose and delete. So that's why fine-grained scopes, time-bound consent, and explicit approval flows are critical. Otherwise, your agent might do things that it was never supposed to do. So when a client initiates an authorization request, so in this case, iOS was the client, it includes a list of scopes. So over here, it's just these two scopes that are pretty broadly defined. And so the authorization server needs to provide those scopes to the client. It needs to publish, like, these are the available scopes, and have a way to display them clearly to the user. So when I'm going through the consent flow, I need to understand exactly what I'm allowing the third-party app or agent to have access to. And also, as I said, be able to selectively consent to the scopes. So this is essential if you want to build trust and avoid blanket consent. And it also helps you build really granular delegation. And another use case is you may want to map the scopes to the roles assigned to the user so that the user can only consent to scopes that they themselves have access to. Like if I only have like viewing access on a resource, I'm not going to be able to delegate write access to an agent. Like that would be something's wrong there. So you can tie the scopes to the roles that a user is already assigned to. So in fintech, these scopes carry real financial and regulatory impact. Delegating payments right without proper guardrails is like giving out a blank check, which, not okay. So once consent is given, it must be logged with the timestamp, client ID, user ID, and the approved scopes. It has to be auditable in case of a breach or compliance check, and it needs to be revocable. Users need to be able to withdraw consent down the line. I need to be able to disconnect and be like, actually, I don't want iOS to have access to all of my Google information. So consent can also be tied to time constraints. So for example, a user might only want to give write access to an agent for the expected duration of a specific task. So tokens issued in response should also include that expiry time. And it's, especially important for short-lived agents doing one-off tasks, apps accessing high-risk data, and also certain regulatory requirements. So after consent, your app issues 3 kinds of tokens. So the client application receives, in the previous diagram, I just noted the access token because that's the most important one here. But there are actually 3 kinds of tokens: the access token, the refresh token, and the ID token. So the access token is typically short-lived, typically 5 to 15 minutes in length, and it grants access to specific resources on behalf of the user because it has those scopes tied in there. So it includes like the subject, the audience or API that the token is meant to be used for, and the issued time. So this is the token that's actually used by the client, the agent, or the app to access those protected APIs on your behalf. The refresh token is a longer-lived token, typically hours to days, depending on policy, and it's used to obtain new access tokens without users having to reconsent. They have to be revocable on logout or suspicion of compromise because these tokens are stateless, so you need to be able to, like when the access token is being refreshed, you need a way to invalidate that. And it should be stored securely and rotated regularly. Then the last one is the ID token, which is only in OpenID Connect specific flows. So those are signed JOTs that represent the authenticated user's identity. So it's intended for the client to verify who the user is, and it's often used to personalize the user experience and not meant to be used for actual API access. So core of it, the access token is the one used by the client or agent to access those protected APIs. The resource server then validates the signature, the expiration, and the scopes. So the access control really happens when that token is checked at the resource server. That is your trust boundary, not the model, as I said before. So unless the agent or app acting is holding a valid token with the right scopes, it shouldn't be allowed to act. So if there's any mismatch throughout any of this, the request should be rejected. So let's do a quick detour and talk about partner app access for a second. We've been talking a lot about agents, apps and services that act on behalf of users, but let's take a detour into a more traditional non-agentic OAuth use case that still really matters. So let's say there's an application, a personal finance app that helps users track spending, set goals, and get nudged when they blow their coffee budget by Tuesday. So let's say you want the users to be able to link their actual bank accounts, which are hosted on, let's say, a platform you're building, your super secure bank. So you, as the super secure bank developer, would want to offer APIs for your partner app, the personal finance app, to be able to get this user data. You don't want the partner app to be scraping account information from your UI. You don't want them to be storing user passwords. That's a big no-no. And you don't want blanket access to all user data without any controls. So that is where OAuth comes in, even outside of agentic contexts. So you would issue the partner app a client ID, they'd initiate an OAuth flow, and the user can log in via your consent screen. From there, you issue an access token scoped to just what they need, so maybe just read transactions and read accounts. So no agents, no LLMs, no fancy orchestrations involved. It's just a clean, standards-based way for trusted apps to access user data with explicit consent and proper boundaries. So this is the same OAuth foundation that powers agentic access. It's just a different flavor of delegation. So the principles really stay the same either way. So if you're building APIs in fintech today and you're not offering OAuth-based delegated access, chances are your users and partners will soon demand it. So I'm going to go into a quick demo because I said all of these things. I talked about the flow. Let's see how that actually looks in a real-world situation. So let me just change this to mirror, so I have the ability to actually control that here. So this is just a sample chatbot application. Let's say I want to have an agent as a part of this chatbot access some information on my behalf. So we have a few different connected services here. So we set up this demo CRM platform that just exposes a couple simple APIs to the agent. So first step is I'm going to have to authenticate. I need to prove that I am Anvi and I'm allowed to delegate this access. So I'll just sign in through Google. And now I'm presented with this consent screen. So connected agent is requesting access to your 10x CRM account. So I can unclick the read deals data is marked as a mandatory scope. The read data of contacts is optional. I'll authorize both for now, but if I wanted to, I could also only consent to one of them. So I'll click authorize. Then I can also, let's say, connect my Google Calendar. And it's the same kind of flow. A consent screen will ask me to make sure I trust connected agent to be able to see, edit, share, and scary, permanently delete all calendars directly. I'll click allow. And now, so what gets returned from that connection flow? If I go over here, I can see that the CRM had been granted the permissions, contacts read, deals read, and then open ID. So that's just my profile information. and the calendar has been granted permission, like the scope directly correlates to their API for their calendar. So now the agent can access these resources on my behalf using that token that got returned from that flow. So if I say get contact details from Jane Lane, for Jane Lane from Globex Corp, it can use that, it basically uses that access token on the CRM's APIs on my behalf. Then I can even say schedule a calendar meeting with Jane Lane on August 12th at 8 p.m. So it'll use the token, it'll use two tokens, one for my Google Calendar and one for my CRM, to first pull the data from the CRM and then schedule a meeting so I can go into this calendar event. Oh wait, I'm actually busy then. I'm attending the MCP Hackathon launch party that Descope is hosting, so if you guys are in the Bay Area, feel free to turn up to that. Sorry, Jane Lane, canceling that. So what's actually happening at the API layer? We basically have set up a middleware to protect the API. So let me zoom in a little more, make it easier to read. So essentially, the middleware checks. First, it validates that access token, makes sure that it's a valid token, hasn't been tampered with, has been signed correctly. And then it checks whether the scopes on the token match the scopes that have been set as required on the API. And it's a very simple, middleware, and same kind of thing can be used regardless of how you're setting up your authorization server. So all you have to do is set that up, say, for this API, I need contacts read, and it's very simple. That enforcement happens if the token isn't valid or it has the wrong scopes. You just return a 401 for invalid token. So let's go back to the slides. So, haven't talked about this yet. Can anyone guess what the elephant in the room is? Or maybe mentioned earlier? So this is a theory I have of what the elephant in the room is. My colleagues tell me that everyone is talking about MCP. I don't know how true that is. I don't know everyone. I don't know whether everyone is really talking about MCP. So my hunch, my theory is that the elephant in the room is MCP. Am I right? Wrong? Okay. How many people in the room are familiar with MCP or are thinking about it? Okay, so it is the elephant in the room. I wasn't wrong. I thought I was crazy for a second. So, quick overview for those of you who don't know. Model Context Protocol, or MCP, is an emerging open standard developed by Anthropic that allows AI agents and large language models to discover and securely communicate with remote services. So, as MCP servers become accessible over the internet, robust authentication and authorization are critical to ensuring that only trusted agents representing real users or tenants can access or invoke tools. So quick architecture overview. A host or an MCP client would connect using the MCP protocol to various MCP servers, and then that MCP server offers some kind of tool that they can process, like local data or connect to remote APIs. So it's just a standardized way. I mean, the hot take is that MCP is fancy APIs. We can fight about that later if you disagree. But it is super important because it standardizes a way for agents to connect to all of these external resources. So currently, a lot of companies are spinning up their own local and hosted MCP servers for both internal and external use, but they struggle at the identity layer. So MCP in numbers, estimated to be 5,000 plus MCP servers currently out there. and approximately 2,000 MCP servers with no security. And surprisingly, only 13% of MCP servers are being deployed remotely, and a lot of that is because it stalls at the identity layer. So what are the MCP identity and security challenges that need to be addressed so that MCP servers can be deployed remotely? One, just general identity security, that's OAuth 2.1, token management and storage, scopes and permissions, function level scopes, user and tenant scopes, incremental consent, enterprise SSO. So you may want to protect your MCP servers with single sign-on depending on who your stakeholders are. Visibility and control, so that's auditing, activity tracking, access management, and revocation. And then just general architectural and operational challenges of building and integrating MCP servers takes a lot of development effort, and there are now cool companies out there that help you do that very quickly and securely, because if you're trying to do it yourself, your error rates may be going up. So all of this might sound a little familiar with everything we just talked about for just general agents connecting. It's a lot of the same identity challenges, just a different use case. So what are the MCP identity standards already set out? So MCP spec now specifies the use of OAuth 2.1 for authenticating and authorizing these interactions. And so that actually allows for consistent access control based on scopes and dynamic client registration. So this enables, as we just spent a lot of time on, OAuth enables verifying the identity of requesting clients, issuing scoped access tokens, collecting user consent, and then supporting token revocation and refresh. So yeah, all of the things we just talked about. So one of the pillars of MCP identity is dynamic client registration. So you won't always be able to pre-register your clients, especially when it's an agent acting. You don't know when someone's going to open their cloud desktop and just want to connect to your server. There's no way to pre-issue that client ID ahead of time. So now dynamic client registration is part of the MCP spec, and that allows OAuth clients to register themselves with your OAuth server automatically. So as a part of that, you define predefined scopes that the client can request, and in return, the client gets their own client ID and client secret. So something that now people really need to start thinking about is the security aspect of dynamic client registration, because you might be having thousands of clients registering themselves, and you also want to make sure that the client is legitimate. So as part of that dynamic client registration, you need to think about things like rate limiting, IP whitelisting, maybe using a fraud tool to tell whether the client should be trusted or not before issuing them that client ID and secret. And then you can also limit the scopes that are able to be used on dynamic client registration and have different ones depending on whether you're pre-registering the client or not. Mentioned this earlier, proof key for code exchange or PXE. So when the client can't securely store a client secret, you can use a code challenge and a code verifier in lieu of the client secret. The next pillar for MCP identity is the authorization server metadata. So the authorization server metadata provides a standardized way for clients to discover information about your authorization server. So in MCP, agents or agentic apps acting as clients can fetch this metadata to dynamically configure which endpoints to use, how to authenticate requests, and how to fetch or validate keys for token validation. And it also lets the client know which scopes are available to request. Finally, we have protected resource metadata. So now, as of last month, MCP servers are now officially classified as OAuth resource servers. So that means that there's now a standard way to expose protected resource metadata, including information about the authorization server. So all of these four pillars basically work together to promote interoperability. An agent now knows how to authenticate and also what's available to them. So quick demo of an OAuth protected MCP server. it basically works very much the same way as the 10x CRM APIs, but it's just wrapped around, there are tools wrapped around the APIs. So this is my Claude desktop. I have this 10x CRM MCP server deployed on Fly.io. So I can click connect here, it'll open up a browser. Same consent flow, but this time we have it set up so that I'm just delegating all access. And then it opens back up in Claude. So now I can ask Claude to, we can make this a little bigger. So get me contact information for John Doe. So it essentially works the exact same way, just the scopes are enforced at the tool level, the MCP tool level, instead of on the API level. So over here, Claude asks me for access, for permission to use this tool. It's a very simple, it's just filtering this API like with John Doe as the name. And so I'll allow once. And so it gives the raw response from the API. And then I can also format it nicely to me. For me, I can say, tell me the deals associated with John Doe. And then it'll call a separate tool, the get deals tool. So, very quick demo, essentially the same thing, but different use cases for being an OAuth protected application. So quickly, let's go over some other OAuth workflows that you might want to think about as you're making your APIs agent ready. So first one I'll quickly touch on is client credentials flow. So that's when a service like a backend job, a scheduler, an agent needs to access a protected resource without any user context, without any end user getting involved. So that's when you need to authenticate the client and authorize it to act on its own behalf. Next one is device code flow. So this is when you need to delegate authorization and without having access to a browser. So like when the agent isn't on a browser. So the agent gets a short-lived device code and user code, and then it can prompt the user to do something like visit auth.example.com/device and enter this code that the agent is presenting to the user. So then the user can log in and provide consent using the same kind of consent flow. And then the agent can just keep polling the authorization server until the authorization server gives approval. So this gives non-browser agents a secure way to get consent without hard-coding credentials or exposing secrets. Last one I'll touch on is client-initiated back-channel authentication, or CIBA. So this is for out-of-band authentication with real-time approval. So if MCP succeeds, if it really is the future, there will be a lot more automated systems, agents acting on a user's behalf. But sometimes there are certain actions that require human in the loop. So CIBA is essentially an OAuth extension for decoupled user authentication. So think about it like a step-up authentication, but for agents. So if an agent, let's say, is approved to do a wire transfer for $1,000, but not necessarily at $10,000, it can push a notification to the user when at the time it's trying to take the action of transferring that higher amount of money, and then wait for the user to approve that, like through a push notification, SMS, and then the agent will only be able to proceed if the user explicitly confirms. So this enforces user control over high-risk operations, and it's just a great fit for fintech use cases where real-time user involvement is required. So I just went over a lot of very detailed OAuth protocols and stuff. But if you take away anything from this talk, I hope it is that identity isn't just about humans anymore. OAuth gives you the foundation for secure delegation. And it's as you're an application developer in fintech, you have to always design for consent and control. So any questions? We have a few minutes. Yes.
One issue I have with that whole OAuth is that I have to once a month go to my Google account and see, oh, who did I allow? Because if you try something, you give an access, and then that tool has access for the rest of your life. So that is similar to, oh, I subscribe to something, and then you pay every month now $15 for something you never use.
Yeah.
But this is now even more scary because you give access to someone that you tried and said, oh, I didn't like it. You stopped using it, but there's no, so therefore my question is there any plans to add an expiry when you say, instead of saying yes, authorize, could I say authorize for a day? And then, of course, the tool would have to somehow reauthorize, but normally it's always unlimited, time-wise unlimited authorization.
Yeah, so that, the question was about, just repeating it, about whether there is any foundation for like time-bound consent or a way to revoke rather than giving access for an entire lifetime. So I think what's fun about this is that everything is kind of still emerging. There are, like in the OAuth spec, there are ways to, store the user consent for a specific time, which is what we recommend doing if you're that authorization server, if you're the one having users access your resources on their behalf. Then we do recommend, along with that user information, along with the scopes, to have an expiration time, and that can live on the access token as well, or on the refresh token. And so then at that point, it's on the application to have a way for users to do that. But that is definitely like a security practice that we recommend.
But it's not very common.
But it's not very common. Hopefully it becomes more common. Yeah. Any other questions? I was once told that I shouldn't say, do you have any questions? I should ask, what questions do you have for me? Apparently that draws more questions, but I think that also works better when it's like more of a one-to-one situation. So what questions do you have for me? Okay, all good. If you're too shy to have the questions now, I'm going to be at our booth, the Descope booth. Thank you all for coming to my talk. This has been fun talking to you all. And yeah, happy to answer any questions, or just if you want to talk about MCP or anything else, happy to have those conversations. Thank you.